In the next couple of lessons, we'll take a look at rendering volumes by using the Arnold Volume object. The type dropdown is used to define the shape of the volume container. You can choose between custom, OpenVDB, box or spherical shape. Let's start with the simpler box and sphere. When these modes are selected, the only thing that we can control from within the container is the efficiency of the sampling. The lower the step size, the more details will be captured, but at the cost of increased render time. The volume container is meant to work alongside the volume nodes. So create a material, apply it to the container, and drag a volume collector in. This node allows us to control the behavior of light as it passes through the container. When parameter is selected in the source fields, the shader is controlled locally by using the scattering, attenuation, and emission options. If, however, channel is selected, the effect will be based on sampling a custom data channel stored in an OpenVDB file or a Turbulence FD container. For the time being, we'll stay with the parameter mode for all tabs. Scattering is used to define the distance a light ray is allowed to travel before it bounces out of the volume. This parameter works hand in hand with scattering intensity, which acts as a strength multiplier. The color option is rather self-explanatory. Anisotropy is used to control the direction of the scattering. It is recommended to leave this value at its default state. Typically, you would like the absorption to be based on the distance traveled by a light ray. That is why the attenuation channel has a convenient option that allows us to reference scattering data. Let's match the intensity and change the color. As red is the value being absorbed, the IPR will render the opposite color, which is in this case blue. Instead of being absorbed, light rays can be set to extinction. Use these modes to gain additional creative and aesthetical control over the brightness of the volume. Let's reset the colors for both scattering and attenuation. As you probably already suspect, we can drive the parameters of the volume collector by using the familiar Arnold shaders. This, however, can be computationally expensive, thus it is recommended to keep the network as minimal as possible. Let's create a simple noise and the color correct. Change the parameters to your liking. And use that to drive the scattering. Set the intensity to 500,000 and change the attenuation mode to extinction. Finally, interesting effects can be achieved when a noise shader is used to offset the volume sampling position. So let's connect the output of color correct to sampling position offset.